Okay, so students, let us start with today's topic, which is the revision of BJT. So the first topic we have started today with bipolar junction transistor construction and working. So now we will start with input output characteristics. So we can write down BJT are of two types, NPN and PNP. So you can write along with me, it will be a good practice for you all. So NPN symbol is like this. Let me draw it a slightly bigger. Please mute your volumes, please. So it has three terminals, just a revision. Base, this is collector, and this is emitter. The arrow indicates that the current is flowing out of the emitter terminal. Now I didn't tell you all this. If I want to write voltages over here, okay, this is base, collector, emitter. If I want to wish to write voltages, this is forward bias voltage, VBE, then this is VCE, okay, and this is VCB. The currents I can denote by IC, IE and IB, okay, and there is a relation between them. Emitter current is equal to collector current plus base current. Alright, and similarly you can do it for your PNP transistor. So I'm not doing it for PNP transistor, I'm just drawing its symbol. This is my base terminal, emitter terminal and collector terminal. Here it is. Alright, so with this background we'll start with BJT characteristics. Okay, so BJT characteristics meaning what? There are two types here over here. Has someone joined? I have to permit them to enter. Just 1 second. What happened? The mic went off or what? Now is it back? The screen is visible now? Am I audible? Okay. So in BJT characteristics we have two types, input characteristics and then we have output characteristics. Okay. In input characteristics we have characteristics versus input current versus input voltage at a constant output voltage, and in case of output characteristics we have output current versus output voltage versus input current constant. So these things are common for input and output generally. Okay, input characteristics meaning it is a graph of input current versus input voltage at a constant output voltage, and output characteristics is a graph of output current versus output voltage at a constant input current. Alright, so there are three different configurations of is this understood? You have written it? I hope I can move ahead, right? I hope you are writing along with me. This will be a good practice for you all. Next we go for BJT configurations. So the way we connect the BJT, it has three configurations. So the three configurations are common collector, short form we call it CC configuration. Then we have common emitter, the most famous common emitter and widely used for amplifier configuration. And then we have common base CB. So what we will do is we'll study the characteristics loosely first, in the sense we'll just draw the characteristics and try to understand, but not so much pay attention to the circuit. Okay, we'll come back to the circuit later. Nope, don't doubt about it. So can we start with the common emitter? Everyone ready? Just give me a check. Ready everyone? Okay, so let's start with common emitter configuration of BJT. Now mind you, we are using NPN BJT. Okay, so how does it look like? First of all, we have to draw a BJT. Okay, now whenever emitter terminal, we draw it like this. Alright, and we place the ground terminal like this, SA. Okay, now it become 2 port, so this will become my input, this is my input, and here is my output, here it is my output. Okay, this is my base, collector, emitter terminal. Now whenever emitter terminal is common between input and output, yes or no? So which is my input circuit? Base and emitter. So base emitter is my input circuit, and what is my output? Common emitter, collector and emitter. So that is my output. And which is the common terminal? Emitter terminal is common. So mostly that's one of the reasons why it's called as the common emitter configuration. Understood now? Just respond yes or no if you're following. Hello? So that I can proceed at same speed. Can you hear me?
Sir, once repeat more.
What should I repeat? This one again. Hello?
Common emitter configuration.
Okay. So the screen was not visible or what in between? Okay, I'll explain. I'll slow down a little. So first of all, you draw the circuit. The symbol of the NPN BJT like this. Okay. Take the ground terminal like this over here and take the port over here like this. Alright. Now this becomes my input and this is my output here. Okay. So what are the terminals over here? Base, this is collector, this is emitter. Yes or no? So now tell me, this is NPN BJT. Okay. Now tell me which is the input circuit. Input side कौन सा है अपना? Base and emitter के बीच में. Yes or no? And what is my output side? Collector and emitter. Yes or no? Hello. Are you listening?
Yes, sir. Yes, sir.
हाँ. Now here input current is what? Let me just magnify this and show it to you. Input current is IB. ये देखो IB मैंने मार्क किया था ना पहले, ये IC है. IB. And what is my input voltage over here? Plus minus VBE. Yes or no? Between base and emitter. And output voltage क्या है? Plus minus VCE. Agree? So what are my input parameters? Input voltage कौन सा है मेरा बताओ? Input voltage.
VBE.
Yes. Input current base and emitter में IB, right? ठीक है? Output voltage
VCE.
हाँ, and output current IC. Okay? Yeah, clear it is? Now
Yes.
we have to draw the characteristics based on this. Okay, so let's draw the input characteristics first. So this is my input characteristics. So it's a graph of, what is a graph of? It's a graph of input voltage. Now input voltage will always come in x axis, remember that, and the current will come in y axis. So this is my IB, ये याद में रखो, this is IB versus VBE. Okay, So it's a graph of input current versus input voltage at a constant output voltage, right? So what is my output voltage? VC. Yes or no? So we'll draw this
Yes.
graph. We will draw this graph. It looks like a PN junction diode. ऐसे ये वाला. So this is for one constant value of VC. Let's say VC equal to 5 volt. Now if I increase the value of VC to a higher value, I'll get a second curve, which is like this. ये इसका explanation is given to you. I am not explaining stuff now. I am just drawing it. Explanation I'll show it to you from where to study. So if you increase the VC value to 10, the graph will look like this. ये clear है? It's like a PN junction diode graph. Yes or no? Agree?
Yes, sir.
Okay.
Yes.
Now ये input characteristics से मिलता क्या है हमें? So if I draw it's very small over here, input characteristics, and if I draw it like this is IB, this is VBE. So if I take a slope over here, ऐसे, if I take this point, ये this exponential is a straight line for a common thing, right? For some point, ये straight line दिख रहा है ना ऐसे? So what is this point? I can say delta IB, और ये वाला point क्या है? Delta VBE. So if I can measure input impedance or input resistance of the of the BJT from the input characteristics. So Rn will be 1 upon slope. So what is the slope of this? y2 minus y1 upon x2 minus x1. ये पढ़ा है ना तुम लोगों ने? Slope is y2 minus y1 upon x2 minus x1. Yes or no? Hello? You understood? Understanding this? Okay. So what is
Yes, sir.
y2? y2 minus y1 is ib1 minus ib2. That is delta ib, and it is divided by delta vb. But 1 upon slope is my resistance. Remember, resistance is voltage upon current. So it will be delta vbe upon delta ib at a constant value of vc. तो हमें input characteristics से what information do we get? We get information about Rn. And what is Rn? Rn is input resistance of BJT. Okay, so this is important. What information do you get from the characteristics? That is also very important. Okay, can I go ahead now? समझ में आया ये? So again I repeat, input characteristics is a graph of base current IB versus VB. Let me write the units. The IB will be in microamperes and VB will be in few volts. So this will be around few volts. Let's say 1.5 to 0 to 1.5. This is the range of the graph. Can I go to the next one now? Any doubts over here? So from the input characteristics you get the information about input resistance of the BJT. Can I go to output now, everyone? Hello?
Yes, sir.
इसका circuit, I will come back to the circuit. I'll modify the circuit as per the practical circuit. Right now we are just moving along. Okay? किसी ने कुछ comment लिखा है? I didn't check, sorry. Okay. No. Fine. So I'm good to go. Now we'll go for output characteristics of this common emitter configuration. Okay, और ये input characteristics I've explained in the working today how it comes, because base emitter junction को forward bias करते हैं, yes or no? So current increases exponentially with VB. So this I've already explained. Now let's go to output characteristics. Now tell me, output characteristics is a graph of what? Output current versus output voltage. Now what is my output current over here? IC. IC versus VC. ये important है. This is important. You should know what is what against what we are plotting. So we are plotting collector current versus VCE. Okay. So we'll draw this graph. Yes. So how does this graph look like? This is VCE versus IC. Okay, so it's a graph of output current versus output voltage at a constant input current. Okay, so how to draw this graph? See this, how to draw this graph, everyone pay attention. uh, please keep the volume. Uh, Hayat, please keep the volume low. Okay, alright. So how does this graph look like? See how to draw it. So first we have this curve. ऐसे बनाना है. ये straight lines रहेगी इधर. That's it. And this is the graph of, this is IB1 at a constant value of different na points. This is IB1, IB2, IB3. ये constant input voltage, input current है. Okay. So and if they join together over here, so this region is called as, ये region को क्या बोलते हैं? This region is called as active region. So active region में the current is almost constant. And then what happens to this current when it goes inside the saturation? और ये saturation region है, यहाँ से यहाँ तक. This is saturation region. We are, in the morning we have seen ना operating mode, saturation, active. So ये region में क्या होता है? The graph becomes, the current becomes suddenly zero. ऐसे. Sorry. Here the current suddenly becomes zero. ऐसे. So we draw this characteristics like this. Are you getting it? Not the other way around. Other way around you are doing it wrong. Okay. And cutoff किधर आता है पता है? There is one more region cutoff. It's almost parallel to the x-axis. Very very small current. So this region over here, where we are writing IB0, let's say, or this is cutoff region. So output characteristics में what we information do we get? From the output characteristics we can determine the region of operation of the MOSFET, of the BJT. So for very small values of VC, BJT is in saturation. For higher values of VC, it's in the active region and current is almost constant. And cutoff is when the current is very very small. Alright? Understood this? Have you drawn the graph?
Yes, sir.
And over here IB3 is greater than IB2, which is greater than IB1, which is greater than IB0. Okay? This is the output characteristics. Now from the output characteristics, what information do you get? So let me draw it over here and show it to you. So we have a graph of VCE versus IC. First of all, what information do we get? We get information about cutoff region. So they can even ask you, show the operating regions in the output characteristics. Then we have saturation region. Then we have active region or forward active region. So we get to know about these three regions. These are called as BJT operating modes or operating regions or modes. Okay. Now ये मैं single curve बना रहा हूँ. I am drawing the single graph. So from there also we get some information. Sorry, it should be like this, and then it goes down like this. So from this curve, what information do we get is here. We find the slope of this curve like this from here to here. So this part we call it as delta IC, and this part we call it as delta VC. So 1 upon slope will give me R out. Okay, slope will be delta IC upon delta VC. So R out will be delta VC upon delta IC at a constant base current. Input current is constant. So what is this R out? R out is called as output resistance of the BJT. Okay, in common emitter mode. Yes or no? So this is called as output resistance. So we get information about output resistance of BJT. Okay. We get one more information. Let me draw one more graph over here. Let's say this graph is over here. Okay, so this is IB2, this is IB1. Correspondingly to that we have, इसके corresponding we have collector current also na, so let's say this is IC2 and इसके corresponding we have IC1. So here the change in the current is also noted down. So this is change in IB and this is change in IC. So the change in IC upon change in IB is called as beta. You have heard of this term beta before? So delta IC upon delta IB is my beta. Beta is called as the current gain of the BJT. Current gain of the BJT. So how much information do we get over here? What all information do we get from the output characteristics? We get information about R out, beta, which is the current gain, and we got also information about the BJT operating regions from the output characteristics of common emitter configuration. Okay, so are you noting it down? Have you completed? Yes, explanation you can write it later, but understanding this is important. Completed? Can I go ahead now? Yes or no?
Yes, sir.
Okay, तो ये हो गया common emitter configuration के लिए. Now we go for common base. Or should I increase the pace or this pace is okay? Hello? Hello? यही speed रखूँ?
Yes, sir.
Okay. Okay, fine.
Okay, sir.
Yeah. Now we'll draw the actual circuit for that common emitter. वो जो circuit था ना अपना common emitter configuration वाला, जो where they have shown somewhere registers also and all that. We'll draw that. तो इसका circuit कैसे हम लोग ने बनाया था? I'll redraw it over here. We have drawn it very simply like this. Let's redraw it. So here we have ऐसे ही बनाया था ना? We have over here base, this is collector and this is emitter, and we have just shown over here its input and output. इतना ही बताया ना हम लोग ने, but actually we should draw it properly. This is just a conceptual part. So let's draw the proper circuit. तो proper circuit कैसे होगा? We will have a BJT. Of course, remember we connected resistors to limit the current only. Okay, so let me first draw only the base emitter. Now this is how we connect the power supply, like this. This we can connect it to ground. So this is your VBE, or we can call it as VBB. Let me call it VBB. And here we have, don't draw it, just wait, I'll explain to you. This is VCC. Okay, ऐसे भी बना सकते हो. We can show the current over here as IB. This current is IB. This current over here is IC. But अगर ऐसे लगाया तो there is a problem of that BJT gets damaged due to heavy current. So to limit the current through the BJT, what we do is we connect resistors. So ये जो resistor है इसीलिए लगाते हैं to limit the current. ऐसे. Let this resistor be RB and this resistor be RC. समझ में आई ये बात? Rest everything is same. Now because there is a resistor, there will be a voltage drop. Okay, so ये terminal and its terminal we call it VBE, and this terminal collector terminal and this emitter terminal will call it VCE. समझ में आया? These are terminal voltages. So let me highlight them: VCE, VBE. Now VBB is the supply voltage. It's not same as VBE because इधर resistor भी है. So resistor के across small drop happens. But that's okay, that's fine. VCE is not equal to VCC. Yes or no? Because we have a resistor in between. So what is the role of the resistor? To limit the current flowing through the BJT. And of course, we can write over here IE, current IE can be marked over here like this, IE out. So IE is IB plus IC always. These are the terminal currents. And what are the terminal voltages? VBE and VCE. Terminal voltages measured at the terminal. So what are the terminals? Base, collector, emitter. So in the exam you have to draw this circuit, not this circuit. ये तुम्हारे concept के लिए था. Actually यही है. Input is this and output is this. Let me mark highlight input. So this is your input circuit, yellow color. समझ रहे हो? And this is your output circuit, the green color. This is one and the same only. Only thing is we have not shown the power supply physically. So in the exam, if they ask you to explain common emitter configuration, you have to explain it with this diagram. समझ में आया? Rest everything remains the same. Understood or no, everyone? To use this circuit. Hello?
Yes, sir.
Okay, fine. Now let's move on to common base configuration. Okay? So write down common base configuration of BJT. Okay, so common base configuration, we have to draw a tilted BJT like this. Alright, this is my common. So over here, which terminal will be common between input and output? This is my input, this is my output. Okay, so this is emitter terminal, right? This is emitter terminal, base terminal, and collector terminal. So what is my input circuit input side consist of? Can you tell me? Input side में क्या क्या है? Base emitter, right? And what is that output side? Base collector. Yes or no? And which is the common terminal between input and output? Base terminal. That's why one of the reasons for calling it common base configuration is base terminal is common between input and output. Clear hai? Yes? And remember this is NPN BJT. NPN. Remember that. Alright. Now tell me input side में से input voltage कौन सा है? What is my input voltage? VB, right? ये वाला ना? So VB is my input voltage. What is my input current? Can you tell me? IE. IE is my input current. So please note it down. Let's go to the output side. What is my output voltage? Output voltage is VCB, right? Yeah, VCB. And what is my output current? IC. ये वाला IC. Yeah. So output current is IC because base terminal is common. So these four are important: IE, VBE, IC, VCB. Okay, this is VBE, IE, VCB and IC. Now इनको ध्यान में रख के we have to plot. So can we start? We'll start with input characteristics. So input characteristics is a plot of input current versus input voltage. Now what is my input current? Tell me what will come in the x-axis, y-axis. X-axis always voltage will come. So it will be VBE versus IE. Understanding or no? Input current versus input voltage. Okay? Are you following this? You are able to understand how we have wrote this terminals?
Yes, sir.
Okay. So the nature of the graph will be again similar to your PN junction graph. So how will the characteristics look like? The characteristics will look like this. again. Okay, and this is at a constant value of what? Output voltage, right? तो इधर दो आउटपुट वोल्टेजेस है VCB2 और एक ग्राफ चाहिए तो यू विल डू इट एट अनदर वैल्यू ऑफ VCB विच इज VCB1. यहाँ पे मेरा VCB2 is greater than VCB1, so let's say this is 10 volt and this is 5 volt. तो ये मेरा इनपुट कैरेक्टरिस्टिक्स है. काइंडली ड्रॉ. Okay, so what information do you get from the input characteristics? I'll tell you now. You get the information about input impedance, resistance. So again you take the slope. इसका slope लीजिए. This is IE versus VBE. So ये क्या हो गया? This is delta IE. And how much is this? Delta VBE. So what will be Rn? Delta VBE upon delta IE. Change in voltage upon change in current at a constant VCB value. So this graph will give me information about input resistance of the BJT in common base mode. समझ में आया? So this is my input resistance. So you should also know what information this graph gives you. This gives me information about the input resistance of the BJT in common base mode. समझ में आ रही है बात? Hello?
Yes, sir.
Now, can we go to the output characteristics now? We are halfway there.
Yes, sir.
Yeah. So, we'll next write output characteristics. So, output characteristics is a graph of, output characteristics is a graph of output voltage versus output current. So, what is my output voltage over here? Tell me. VCB. And what is my output current?
IC.
Yes. तो ये ग्राफ को कैसे बनाना है ध्यान से देखिए. You leave some space on the left hand side also. So this is VCB versus IC. Alright. यहाँ पे the collector current is almost constant for majority of the part. इधर देखो. It is almost constant. So draw these constant lines. ऐसे. Oh, sorry. I have to draw it upwards. So these constant lines will be like this. यहाँ पे देखो पूरा 0 तक जा रहा है. Constant lines. बनाया ये? तो this region of operation is called as active region. ये मेरा active region है. In common base mode. And what are these things? These are different values of IC. IC1, IC2, IC3. Are you following?
Yes.
And this graph is not complete. Zero यहाँ पे है. It is going in a negative side. Okay? तो कैसे complete करोगे graph? ऐसे एक point में. At one point. Like this. So this is the actual graph of output characteristics. This goes negative. And ये जहाँ पे negative होता है, that this region is called as saturation region. Okay? And where is my cutoff region? Cutoff region is almost parallel to the x-axis. यहाँ पे. तो ये मेरा cutoff region है. This is IC0. ये cutoff region almost very very small. So this is cutoff region. So this is how I show all the three operating regions of BJT on the output characteristics. And और ये common base mode है. Remember, this is common base configuration. Okay? And what information do you get? तुम लोग कर रहे हो ना? Oh, sorry, one mistake. This is IE, not IC. IE. IE है ये. Please change it. IE. So now we'll understand what information do we get from these graphs. Again, can you tell me what information do we get? ये almost like straight line बनाया है आपने, but थोड़ा सा tilted रहता है. Slightly moving upward ऐसे थोड़ा सा at a very high point. So if I take the slope of this, what it will be? Delta, what it will be almost, tell me. Delta IC upon delta VCB. So it will give me output resistance of the BJT, which will be delta VCB upon delta IC at a constant input current. IE is constant. Okay, so एक information मिल गया. One information was it tells us about the operating regions of the BJT: saturation region, active region, and cutoff region. Second, it gives information about the R out. Third, it gives information about the relation between IC and IE. Now यहाँ पे देखोगे, if I extend it over here, if I check the graph at two different points, this is IC versus VCB. This is IE1, let's say IE2. This is IC1 and IC2. As you can see very clearly, both are almost related to each other, almost same. So there is one more quantity defined as alpha, which is delta IC upon delta IE. This is also called as current gain. तो ऊपर वाला भी एक current gain था, that is called as common ammeter current gain. This is called as common base current gain, and this current gain almost alpha is less than or equal to 1. So IC is approximately equal to IE, almost equal to 1 in this case. So this is my current gain. So these three information do we get from the output characteristics of common base configuration. समझ में आई ये बात? Again, this is current gain. So it gives information about saturation region, cutoff region, active region. It gives information about R out, output resistance, and it gives information about alpha, which is IC, delta IC upon delta IE. Sometimes we also write like this: alpha is IC upon IE. तो दोनों में फ़र्क क्या है? ये DC वाला अल्फा है, ये AC वाला अल्फा है. अल्फा AC, अल्फा DC. Mostly both are same. And alpha is current gain, which is less than 1. Understood this? Can we move on to the next one now? लिखा है सब कुछ?
Yes, sir.
Okay. These are the facts which we are describing. I'll help you out at the end how to write them as answer forms. Now we go for common collector. Is the least used actually. Common collector is used as a voltage buffer mostly, but in common configuration. Let me open the document again. Okay, so now we go for common collector. For common collector we can okay, one more thing is left. What is left? The circuit diagram. How to draw the proper circuit diagram? We have to check, right? तो हम लोग ने कैसे बनाया था? We have drawn it like this. हम लोग ने ऐसे बनाया था ना सर्किट डायग्राम. This is input, this is output, and that's it. This was your emitter, collector, and base. But exam में तुम लोग ऐसे नहीं बना सकते. In exam you have to draw it properly. Like for example, let me show it to you how to draw it. So you have to also show some resistors. Okay. So this is the base terminal which is going to the ground, of course, and on the right hand side you can draw the power supply. So power supply will be this way. It is, see, we have to forward bias it, right? Base emitter junction always forward bias, base collector reverse bias. So ये base emitter junction है, तो this is N P N. So N को हम लोग negative दे रहे, तो ये forward biasing this, तो ये correct है. This voltage is called as VEE. Okay, and on this side base collector junction, this is collector. Base collector junction should be reverse bias, right? So यहाँ पे positive voltage दूंगा. समझ में आ रही है बात? And this I'll connect them together. So this becomes your ground. Okay, this voltage we can call it as VCC. Alright. Now normally to limit the current, as I told you again, पहले भी ऐसे किया था हम लोग ने. To limit the current through the BJT, we connect resistors. So we can connect resistors over here also. So here we connect the resistor, we call it as, anyone knows what do we call this resistor as? RE. And here we can show the resistor as RC. Alright, this to limit the current, that's it. What is the current direction over here? यहाँ पे ये current direction है I का. This is the current direction for IC. Oh, IC current direction, and IB current direction is like this. So the current important terms are IE and IC. Now what are the terminal voltages which we have not marked so far? अभी तक mark नहीं किया है, वो कौन से terminals है? ये वाले. So you call this plus minus VBE यहाँ पे, यहाँ से लेके यहाँ तक, correct? And then you can also show VCB. So VCB मतलब यहाँ से लेके यहाँ तक है, यहाँ पे plus, यहाँ पे minus. So this is VCB. समझ में आई बात? So these are called as terminal voltages, VCB. So VCB, VBE is not equal to VE, yeah? VBE is not equal to VE because of this resistor, and VCC is not equal to VCB because of this resistor. So this diagram, if they ask you in the exam, draw this diagram and not this diagram. अगर याद नहीं आ रहा है तो you have to draw it starting with this, leading up to this. समझ में आ रही है बात? And always bias it such that it becomes in the forward active region, in the active mode. मतलब base emitter junction should be forward bias, base collector junction should be reverse bias. So connected in this way always. This is the hint to you. Okay, understood this? Can we go on to the common collector now? ये डायग्राम बनाना है, प्रैक्टिकल डायग्राम. ओके, हेलो. So now we go for common collector. This is the least sort out configuration. Normally we don't operate in common collector very often unless it is a unity gain. So it's connected like this. We connect the emitter up. So this is my emitter terminal, this is my base terminal, and this is my collector. So collector terminal is common between input and output. Okay, now quickly tell me which is my input current, output current over here. So IB is my input current obviously, and what is my input voltage?
VBC.
हाँ
VBC.
हाँ VBC. यहाँ पे आउटपुट करंट कौन सा आएगा? IE और IB. Which will IE, right? IE will be my output current, and what will be my voltage?
VCE.
हाँ VCE बोल सकते हैं यहाँ पे पॉजिटिव टू नेगेटिव ऐसे दिखाना पड़ेगा. एक्चुअली VBE की जगह VBC की जगह we have to write it like this. I know base terminal has to be at a higher potential, but we can show the input as VCB. ऐसे positive here. I mean, it's okay. We can show it as VBC also. No problem at all. Okay. So what are my input current? IB. Input voltage VBC. Output current IE. Output voltage VC. So need not write this again. Okay. So we'll directly go to the output characteristics now. Fine. Input characteristics, sorry. So input characteristics is a graph of input current versus input voltage. So we can show over here as VC or VBC versus IB. Alright, this is NPN. Okay, so how this graph looks like? This is a strange curve actually. The graph looks like this. See carefully, like this. Two lines. For a constant value of VC1, output value constant VC1, and here it is VC2. Like this we can show. Actually this we determined using VCB mostly. So this you write it as VCB. So this is the graph of input characteristics, and this graph will give me Rn. What is Rn? This slope, ये वाला slope. Okay, so this value is how much? Delta IB. What is this value? Delta VCB. So it's a delta VCB versus delta IB at a constant output voltage, which is VC. So it gives me information about Rn. Rn is very very high, very high. Input resistance or in common collector mode is very very high. That's one of the applications. It's used as a buffer mostly because of its high input impedance. Because denominator में we have delta IB na, and delta IB is in microampere range. Alright. So this is the information we get from the input characteristics. Not much. Now we draw output characteristics here only. So output characteristics looks exactly similar to your common emitter mode. This is VCE versus IC. So it's IE, sorry. Instead of IC, we have IE. Now IE is almost similar to IC. That's why the characteristics is almost same as your. Which characteristics we are talking about? Output characteristics in common emitter mode. Same almost. Like this we have to draw. See? And the operating regions are also same. Only thing is here we write IB3, IB2, IB1. What is changed? Instead of there we had IC, here we have IE. That's the only difference. Rest everything is same. So you can show the operating regions over here. So this is active region. I have shown this. This will be saturation, and over here there will be one curve which is almost parallel to the x-axis, which is IB0, and this value is cutoff. Okay, and output characteristics say what do we get? R out, which is delta VCE upon delta IE at a constant IB value, input current constant. So this graph gives me information about R out, output resistance of the BJT, and output resistance of the BJT is very very low. So that's one of the features. Its input resistance is very high, output resistance is very very low. Okay, and normally in common collector mode, whenever we connect the BJT, it's used mostly as a buffer, not as an amplifier. Alright. You have any doubt or a query, you can ask me. Any doubt, anyone? Is practical circuit, you can draw it on its own, you can try it on your own. Okay. So that is it from my side for the input and output characteristics. So how much I have covered this, I'll show it to you. Today morning I have revised these symbols, construction, working. I'll give it to you how to write it. Then input output characteristics we have discussed just now for CB, CC and CE, and their comparison. I'll give it to you. Then application of transistor as an application of BJT as an amplifier and as a switch, I'll just now cover it. So this part is covered to you. Agree? Thoda about. Now we'll go to the how to study this. Can I go back one of the PDFs? I have shared with you one PDF called as BJT extra material. So open that. I have done the markings for you all. See, whatever of tick mark you have to study. So for the construction, can you see this PDF, everyone? Hello.
Yes, sir.
हाँ तो मैंने मार्क करके दिया है. दिस इज द आंसर टू द कंस्ट्रक्शन पार्ट. मतलब ये बनाना है NPN और PNP. Here the construction is given to you, the description of it. Okay, ये हो गया ट्रांजिस्टर कंस्ट्रक्शन. Whatever of tick mark you have to study. ये भी पढ़ना है. Arrowhead क्या होता है? Arrowhead is the conventional current. Then the working of the BJT. This much is the answer. ये पूरा पेज है ना, यहाँ से लेके यहाँ तक. Let me mark it in red color. From here till here. You have to write the answer अगर working of BJT पूछा तो. ठीक है? Agree? समझ गया? And this is what we have done in the class in the morning, right? ये forward bias होना चाहिए. तुम लोग और एक चीज बता सकते हो यहाँ पे. You can show the depletion junctions. ये वाले layer. ये नहीं बताया. This is base emitter junction. And this is कौन सा junction है ये? Base collector junction. You can show this and rest all you can keep it same. समझ में आई ये बात? So this is the working of the BJT which we have discussed in the morning lecture. Then along with the working, if they ask you for 10 marks, you have to explain the region of operation also. मतलब यही ग्राफ में इसका ग्राफ आएगा output characteristics का. So you have to explain the region of operation. In cutoff mode, both the junctions are reverse bias. In active mode, emitter base junction is forward bias, base collector base collector is reverse bias, and the saturation both are forward bias. ये हम लोग ने discuss किया था, right? So this also we have to write in the working. Okay, and this the biasing is done in the active region. Now for the configurations you can write it like this, or you can skip it to directly this. हाँ ये relation कभी कभी पूछते हैं तो do this and go. What is simple है, ये लेके जाना, ये लिख के जाना, पढ़ के जाना ये. This you study and go. Relation between alpha and beta. So beta is alpha upon 1 minus alpha. Okay, or we can write alpha as 1. I mean there is a relation between alpha other way around also, but that's fine. Beta is alpha upon 1 minus alpha. Then ये वाला रहने दो. Then comes the transistor characteristics. I explained you the characteristics today, right? ये उसका working है. This is the working of it. So you can check on it. ये input resistance is same. So if you get time to read, you can read, or else just remember the characteristics. ये उसका output characteristics है और उसका description. So you can refer this point. Are you understanding? Yes or no? Hello, you're following how to study this PDF?
Yes, sir.
Then next is common emitter. Common emitter में input characteristics description is given over here. Input resistance is given. Output characteristics, देखो ये output characteristics है और उसका description यहाँ पे दिया हुआ है. So you can study that directly from there, and that is accurate. ये accurate है थोड़ा. Okay, that's it. So from this PDF only study this much. Working, input, output characteristics in common emitter and common collector mode. Alright? ठीक है? Now we'll go to the next PDF. Configurations वाला. ये खाली देख सकते हो तुम लोग. You can overview it. It's the same thing which we have done in today's lecture. And I've recorded this lecture also. I'll share you the recording also. Okay? तो ये खाली grasp करना है. Quick reference के लिए. Now we go to application part. Abhi right now we don't have much time for it, but I'll explain you in a brief. BJT as an electronic switch, we can operate it in either in the cutoff mode or in the saturation mode. So whenever the transistor is in cutoff mode, it behaves as a short circuit, ऐसे. And whenever transistor is in saturation mode, oh sorry, other way around I said, whenever it is in the cutoff mode, it is in the open circuit mode. So ऐसे open circuit switch. Whenever it is saturation, it behaves as a closed switch. That much only you have to remember. Okay. So here what I've explained is, I'll explain over here. BJT as an electronic switch operates in two modes of operation, that is cutoff and saturation. Cutoff means fully off, saturation means fully on. So that's the property of a switch, right? On and off state. So here is my circuit diagram. We have applied input over here with via a resistor to the base terminal, and we have taken the output across the collector terminal. A load can be connected. A load can be a motor or a LED. Okay, and whenever input V in is less than VBE, your transistor is not on, and base current and collector current are almost zero. So what will happen is this transistor is off. It will behave as an open circuit, and output will be pulled up towards VCC level. Okay, so ये off हो गया. ये देखो explain किया यहाँ पे. This is off. So BJT will act as an open switch, and the current across this load will be zero. So whatever voltage at VDD is, same will appear at the Vout. So Vout will be equal to VDD in this case. Okay. So if there is a motor will be off with a zero current. If the load is LED, then the light output will be zero with zero current. LED will not glow. So here it will act as a closed switch, open switch. Sorry. Now, whenever V in is equal to VCC, whenever V in is equal to VCC, means we apply a very heavy voltage, the transistor will go into saturation. So it's fully on. So once it is fully on, it will behave as a closed switch. उस time पे VC voltage is very very small. So what will happen is your output voltage will drop towards VCC or VCE level. So my output voltage is almost equal to VC sat. We say that value is very very small. Okay, so that means maximum current is flowing through the circuit in this case. So I can say here the switch behaves as a closed switch. And if we connect a motor, the motor will run at a speed. And if we connect a LED, it will glow. LED will glow. Okay, so these are the assumptions which we are making. This is just the output characteristics. This is the cutoff, and this is the saturation mode of operation. I can briefly explain you this much only in limited time. Then we'll quickly go to the amplifier. Amplifier I expect you all to read. We'll discuss it later on. You can read this PDF if you understand well and good. If not, then you can read still and check whether you can understand it further. So BJT acts as an amplifier when you operate in the active mode of operation. That much you remember. So you go through this topic. I have an old recording of mine I can share with you for this topic. Okay. Then someone have given me some questions there. They have explained BJT biasing. So this video is already available. I'll share the video with you all, and that explains the BJT biasing also, DC biasing. Okay. So yeah, you can refer this PDF for BJT applications. Okay. So that's it from my side.